This is a video accompanying the paper Learning Adaptive Control for SE3 Hamiltonian Dynamics. We consider the problem of learning an adaptive controller from data collected under different disturbance realizations. The goal is to learn a pair of trajectory tracking controller pi that compensates for the disturbance and an adaptation law that estimates the disturbance online. We consider the robot state on the SE3 manifold and enforce the SE3 constraints and the law of energy conservation. Our approach to the problem has two stages: an offline Hamiltonian-based dynamics and disturbance model learning, and an online adaptive control stage. In the offline stage, we design the architecture of the neural ODE network using Hamilton's equations on the SE3 manifold, with parameter theta for the Hamiltonian dynamics and parameter phi for the disturbance model. This structure guarantees a law of energy conservation and the SE3 constraint by construction. In the online adaptive control stage, the learned Hamiltonian dynamics parameter theta is used to design a trajectory tracking controller pi from an energy-based perspective. The disturbance parameter phi is used to develop an adaptation law that estimates the disturbance online. And then we combine pi and rho to create an adaptive control with stability analysis provided in the paper. We verify our learned adaptive controller on a pi-bullet simulated quadrotor with two disturbance sources: external winds in the world frame and defective rotors, which can only operate at a certain percentage of the nominal value. For training, we collect state control trajectories under 8 different realizations of the disturbance. In the first demo, we assume a constant winds and defective rotors at 80% of the nominal thrust. So without adaptation, the drone drifts in X, Y, and Z direction caused by the disturbances. Meanwhile, with adaptation, the drone can estimate the disturbance after a few seconds. Then it can compensate for it and successfully track the trajectories. In the second demo, we also have a constant wind, but the rotor becomes defective in the middle of the flight after 5 seconds. So without adaptation, the drone drifts and drops to the floor after 12 seconds. Meanwhile, with adaptation, the drone is able to recover from the rotor defects and finish the task successfully. Thank you for your attention. We invite you to visit our project website and check out the paper for more details.